solving the system of linear equations using the inverse method. Given the system of linear equations, the first step is to write down the matrix of coefficients. So I just take the coefficient of A, which is 1. Here we don't have B, so we have 0, and the coefficient of C is 2, and the rest follows. Now we are looking at vector X, which contains A, B, and C. And the vector B is the solutions of these equations, which is 1, -2, and 1. Now, for us to use the inverse method, this system of linear equation, I can call it star, can be written as AX is equal to B. You can see that if you multiply the matrix A with X, which is ABC, will give you the left side of the equations, and B is the vector. So we can write this system as follows. Pre-multiply by inverse, so that is A inverse multiplied by A, which is identity, multiplied by X is equal to A inverse, or the inverse of A multiplied by B. So since an identity multiplied by any vector or any matrix is the matrix of the vector itself, so we have X is given by the inverse of A multiplied by B. So this system has solutions, or a solution if and only if the determinant is not equal to 0. So the next step will be to determine the determinant of the matrix. So I will use this method. Here we take the first two columns, that is 1, 3, 1. Then we get 1, 0, 1, and -1. So I will take the product, that is 2. I take the product, that is 0. I take the product, that is 0. I take the product, it's -2, 0, and -6. Products in the major diagonal, we have -2 plus 0 minus 6 minus, we have 2 plus 0 plus 0, and this is, that is -10, which is not equal to 0. So the system of linear equations has a solution. Now the next thing is to calculate or to find the minors of this system. Okay, so minors are simply determinants or small determinants after deleting some rows and columns as follows. So I have this matrix. So to find the minor in the first entry here where there is 1, I will delete the first row and the first column. So the remaining matrix here, a 2 by 2 matrix, is the minor of A11. So we have 1, -1, 0, and -2, which is this one. So I just find the determinant and put it there. The next one is the second column. So simply to find the minor, you delete the entire row and the entire determinant where the element lies, and the remaining matrix is the remaining matrix you just find is determinant. So on 0, I will delete the first row and the second column. So what I'm remaining with is 3, 0, and 1, and -2. Okay, so you can go ahead. Let's say I want to find the element here on -1, so -2. So I will delete the last column and delete the last row. So I remain with 1, 3, 0, 1, and the rest follows. So meaning the matrix of minus will be, so I take the determinant here. This is -2, and this is -6, and that is -4, and the rest follows. Next, we are going to find the matrix of cofactors. So simply, the matrix of cofactors is just the matrix of minors that has been assigned to the corresponding sign. Since this is a 3 by 3 matrix, we are going to have the signs as follows: positive, minus, positive, minus, positive, minus, positive, minus, positive. So the signs are simply alternating. The other way of looking at the signs is by determining -1 to the power ij, okay, where I represent the column and j represent the row. So for example, if you are in the first column and first row, you have 1 plus 1, that is first column, first row, or first row, first column, 1 plus 1, and it is, which is 2, and -1 squared is +1. Okay, if the sum is odd, then you're going to have a negative. So you can see here, this is 1, 2, which is 3. We have a negative here. Okay, so if we take the product there, or just switching the signs respectively, you have, this is positive, this is negative, and the sign is positive, you remain positive. This is negative and the sign is negative, you have positive. Okay, and this is negative and the sign is positive, you have negative, and the rest follows. Having found the matrix of cofactors, we are going to find the adjoint. Now, the adjoint is just the transpose of the matrix of cofactors. So we transpose this matrix, which is 2, -2, 6, -4. And finally, to find the inverse, we say 1 divided by the determinant of A multiplied by the adjoint of A. And remember, the determinant is 1 is -10, so we have 1 over -10 multiplied by the adjoint. So we have that. All right, so we are just one step away. Having found the inverse of the matrix, we can now solve the systems of linear equations. So now we said x is given by A inverse P, and this will be equal to, so we are going to take the product as follows. Our B is 1, -2, and 1. And when we take the product is 0. And the rest follows 2, -2, and 1 over 2. So finally, A is equal to 0, B is -2, and C is 1 over 2. And we are done. Please like, follow, and share for more videos.